In this segment, we will take up a problem which deals with shear stress, that is under the general topic of state of stress. Now, the problem goes like this. These green color ones, they are two, in a way, we can think of them as two rubber blocks. Okay, so these are two rubber blocks. This is one, and this is the other one. And which are glued to this orange color steel plate in a way. Okay. And the dimensions are given like that: 4 inches width, 6 inches height, and the thicknesses of the rubber pads are given to be 1.25 inches each. Now there is a force P applied on this upper surface of this steel block, and then these two rubber blocks, because they are glued, so they will try to deform and resist this force P. We are supposed to find out the stiffness constant K, which is defined by the applied force P over delta. Okay, and this delta is the total deflection that this P goes through. Okay. Now, and then we have to evaluate this in as a function of the shear modulus, then the area, and this deflection, and this thickness, say T. Okay, so these are the parameters in which we have to evaluate them. Okay. Now, so let's say I don't think it will be a function of delta, because delta will be you know divided, so it will be a function of T only. Okay, yeah, fine. Actually, the function I was thinking of, the force P. Yeah. So then let's figure out. Let's see what would be the shearing strain that we will get. Shearing strain will be, see, once we look from this side, the rubber blocks will look something like this. So they will be deformed in this way, right? So like that, they will be deformed. This is one of the sides. The other side also will be deformed, something like that. Maybe I'll shift this thing a bit here. So the other side also will look something like this, and this is the deflection delta, and this is the thickness T, right? Now the gamma is nothing but delta over T, because everything is small, and tan theta is theta, sort of, in that approximation. Okay, so delta over T is gamma, and the shear stress that will be developed on these sections. Okay, so this is the section which will be subjected to the shear stress, and that shear stress will be G times gamma, which will be equal to G delta over T, and each of them will be subjected to a force of P over 2, and this side also P over 2. That means P is 2 times this, so that means P will be, but because both the surfaces are resisting this, is equal to 2 times G delta, but then it's the stress, so to get the force we will have to multiply with the area. Okay, and yeah, divide by So this is what I was talking about, the force as a function of all these parameters. Then the stiffness which we are supposed to find out is nothing but P over delta, which is equal to 2 GA over T. Okay. So this is the stiffness which we were looking for. Um, uh, for example, suppose we want to see some typical values for rubber materials. Typically G will be say 2.75 um, KSI. Okay, then say what a area we have, say 24 inch square, and say thickness is 1.25 inch. If you substitute all these values, the K which you will get will come out to be 105.6 into 10 raised to 3 pounds per inch. So this is just a representative value. Okay, so that is it. So see you in the next segment with another problem.